Welcome to a course on sequence and series. In this lecture, we are going to continue with monotonic sequences and especially we are going to work out few problems on monotonic sequences. Let us get into the lecture. In this problem, we are asked to consider a particular sequence. The general term is defined in this form and we will have to check whether the sequence is convergent or not. And if it is convergent, we will have to find out the limit of convergence as well. Let us see how to find it. Right? First, let us try and find whether the sequence is monotonically increasing or not. Okay. So, in order to check the monotonic increasing or not, what do? We will have to calculate Sn plus 1 minus Sn. This quantity we will have to calculate. What is Sn plus 1? It is summation k runs from 0 to n plus 1 upon 4 upon 10 power k minus summation k runs from 0 to n 4 upon 10 power k. Right? So this quantity we may write it as summation k runs from 0 to n 4 upon 10 power k plus 4 upon 10 power n plus 1 minus summation k runs from 0 to n 4 upon 10 power k. So this quantity gets cancelled and we are left with only 4 upon 10 power n plus 1. Okay, this n can take any value in the set of integers. Hence, this is a positive quantity, this is also a positive quantity, and hence this is a positive quantity. Which means what? We have Sn plus 1 bigger than Sn, and hence Sn is a monotonically increasing sequence. Right? So, if it is turning to be a bounded one, we can say it is convergent. Right? Okay. Physically, what do we mean by a convergence? It has to approach to a finite limit when n approaches infinity. Right? So, we can directly make use of that idea, or we may use this idea as well. Now, we'll see whether this is bounded or not. Okay. Here you may notice that it is the basic geometric series. Right? So, in the geometric series, we are going to take only a certain limit. Okay. If we are going to consider only one term, that is our first element in the sequence. If we are going to take the sum of two entries in the in the series, that is the second element of our sequence. If we are going to take sum of 10 entries in the series, that is our 10th element in the sequence. That is how we have defined it. Right? And hence, let's see what is the common ratio here. The common ratio here is 1 upon 10. Right? So the quantity is lesser than 1 and hence this term will be a bounded one. Okay. If you look for the boundedness of this sequence, it will be a bounded one. For example, if you try to let us try to find out the range of the given sequence Sn. So when you give n is equal to 1, you will have what? So it is going to be 4 plus 4 upon 10 for n is 1 category. Then 4 plus 4 upon 10 plus 4 upon 10 square. It is 4 plus 4 upon 10 plus 4 upon 10 square plus 4 upon 10 cube, and it goes this way, right? So what is this? This is 4 plus 0.4. It is 4 plus 0.4 plus 0.004. It is 4 plus 0.4 plus 0.004. Sorry, 0.04 plus 0.004. And it goes this way, right? So this is what? This is simply 4.4, 4.44, 4.444, and it goes this way. Here easily you may notice that this is a bounded sequence. Even though the n value increases, it is going to be what? It is going to be, you will have 4, 4, 4, 4, 4, 4, 4. So to the maximum, we may take 4.5, 5. These are all upper bounds of this range, this set. And hence these are all some upper bounds of the given sequence as well. Therefore what? Therefore Sn is bounded. Right? If we are asked to find out only the convergence, means we have proved it is a monotonically increasing sequence, and also we prove it is bounded. Hence we may conclude that it is convergent. But we are asked to find out the point of convergence as well. In order to find the point of convergence, we will have to do what? We have to find out the supremum of this set. That is limit n tends to infinity Sn. This is what we need to find out. Limit n tends to infinity in summation k runs from 0 to n 4 upon 10 power k, which means we will have to find out this thing. Right? So we have the formula, that is a upon 1 minus r. So here a is what? Okay, and here when you give a is going to be 4 upon 1 minus 1 upon 10, it is what? 40 upon 9. Right? This is the limit to which the sequence converges. Next, we are going to check the convergence of the sequence. Sn is Sn plus 1 is under root 2 times of Sn, and S1 is under root 2. Okay. For rest of the values, it is defined in this form. We are going to check the convergence of this particular sequence. Now, what we will do is that first of all, we will check whether this is monotonically increasing or decreasing. That is, we are going to check whether this is a monotonic sequence or not. Then we will look for the boundedness of this sequence. When the monotonicity and boundedness are present for this sequence, we may come to a conclusion that it is convergent. Right? Next, we will try and find the limit of the convergence. That is what we are going to do now. Okay. What is given? We are given that Sn plus 1 is under root 2 times of Sn. Right? We will have to find out what? In order to check the monotonicity, we need Sn plus 1 minus Sn. This is what we need, right? In order to get that, what we are going to do is that we are just going to square it. So when squaring on both sides, it will give you Sn plus 1 square is 2 times of Sn. Okay. Similarly, what is Sn? It is under root 2 times of Sn minus 1, and this gives you Sn square is 2 times of Sn minus 1. Right? So here, instead of checking this, actually we are going to check this, for which we are considering this, and this is going to be what? 2 times of Sn minus 2 times of Sn minus 1. This is in the form of a square minus b square. Hence, it may be written as Sn plus 1 minus Sn times of Sn plus 1 plus Sn, and which is 2 times of Sn minus Sn minus 1. Right? Here we may notice that this S1 is a positive quantity, hence all our Sns are going to be positive quantities. So sum of two positive quantity is always positive. Right? So this is not going to affect anything here. Based on this value will be decided. Okay? That is, if Sn minus Sn minus 1 is bigger than or equal 0, then Sn plus 1 minus Sn will be bigger than or equal 0. Suppose if this is smaller than or equal 0, then this will be smaller than or equal 0. Okay, this value is going to decide. Okay, similarly, right. So this is the value that is going to decide the nature of this. So for which we will have what? If we do of similar sort, we will have this value will be decided based on Sn minus 1 minus Sn minus 2. Okay. When we come down to the least, what we are going to have is that S2 minus S1 will decide all the values. Okay. What is S2? We know that S1 is under root 2 here. S2 is this quantity, right? So we know that it is positive. So this is positive, and this is going to tell you that, okay, when we write it in a formal way, since this is true, okay, our Sn minus 1 is a positive quantity, which implies Sn plus 1 minus Sn is a positive quantity, and hence Sn is monotonically increasing sequence. We have the monotonically increasing one. Now we will have to check the boundedness, right? So for which let us consider this one. We know that Sn plus 1 is what? Sn plus 1 is 2 times of under root Sn, and we know that Sn plus 1 is bigger than S1 since we have proved it is a monotonically increasing sequence, right? And now what? Okay, substitute this here. 2 times of under root Sn is bigger than Sn, right? When I square it on both sides, I am going to have 2Sn square is bigger than, 2Sn is bigger than Sn square, and I am going to take everything to one side, so this is the case I have, right? And here Sn times of Sn minus 2 is less than 0. From this we know that Sn is a positive quantity, right? Hence this implies what? And hence Sn must be less than 2. This is what we have, right? So combining these two things, what we have? 0 less than Sn less than 2. Therefore what? We are able to identify upper and lower bounds of this sequence. Hence Sn is a bounded sequence. Okay, we have proved it is monotonically increasing, and finally we have proved it is bounded, and hence the sequence is going to be a convergent sequence. Now the question is to find the limit of the convergent sequence, right? Now, okay, what is the thing? Again we will start limit. Let us take limit n tends to infinity Sn is equal to L. Okay, when limit n tends to infinity Sn is equal to L, then this also tells you limit n tends to infinity Sn plus 1 is also L. Right? Now you have this, right? So take Sn plus 1 is equal to under root 2 times of Sn. Okay, just square it. So Sn plus 1 square is equal to 2 times of Sn, and take limit. What are you going to get? You are going to get this is L square and this is 2 times of L, and this implies L is equal to 2. And what is L? This is limit n tends to infinity Sn is equal to L, and that is 2, and hence the sequence converges to 2. Thank you for watching.